Distance to a beam of a lighthouse. Practice problem 3. ETA to a beam. Practice problem 3. Good. Now we'll get into the problem, and it's giving us information here. Right away it says, your vessel is on course 255 true. We're given a course. Course equals 255 degrees true. This helps us make our triangle. At 14 knots, our speed equal to 14 nautical miles per hour. Then it gives us a time. At 21:26, a lighthouse is sighted dead ahead at a distance of 11 miles. So the time is equal to 21:26, 21 hours, 26 minutes. Sighted dead ahead at a distance of 11 miles. So it gives us a distance equals 11 nautical miles. You change course at this time to pass the lighthouse 3 miles abeam to port. It gives us a second distance. We're going to call that distance A, for distance abeam. And it says how long? 3 nautical miles to port. Okay, what will be your ETA at this position? It wants to know ETA. What's your estimated time of arrival to a position 3 nautical miles to the port? What is that? Okay, so now we can start to solve this problem. We'll draw our triangle, right? It said, okay, to port. It said, boom, 255. 270 would be this way, right? So if we're here, 255 somewhere like this, and we sight this lighthouse dead ahead, and we want to leave it 3 nautical miles to port, which means our next course is going to be over here, right? Then we're leaving it to our port side. And it's going to be directly abeam, meaning this is a right triangle. And so we sighted this light how far away? 11 nautical miles. 11 nautical miles away. And then this distance abeam was 3 nautical miles, and it's to port. Okay, and now we're going to label these, right? This is the hypotenuse. It's across from the 90. It's always the longest side, and we're always going to call it C. So this is going to be C. We're going to call this one A, and this one we'll always call B, this distance here. And we're going to find this distance so we can find how long it takes, because we're given a speed, and then we can add it to here, and we'll get an ETA. So now that we have our triangle drawn, ABC, we can say that A squared plus B squared equals C squared. That's the Pythagorean theorem. And we're going to solve for B, right? The only one we don't know is B. So if we minus A squared from both sides, it crosses off here and goes over here. And we get B squared minus, or equals, C squared minus A squared. And now we can plug in our numbers. What was C? 11. It was 11 nautical miles squared. Minus, what was A? 3. 3 squared. Okay. And now we do this math. 11 times 11, or 11 squared, is 121. And 3 squared is 9. But I'm going to show you on the calculator so you have a good understanding of what buttons to hit. On, clear. And so to get 11 squared, we go 11, see this button, this X with the 2, squared equals 121. Okay, so 121 minus 3 squared is just 3 times 3, it's 9. 9. So 121 minus 9 is 112. 112, right? 112 plus 9 is 121. Good. So B squared equals 112. To get rid of this 2 and figure out what just B is, we would take the square root of both sides. So we say b is equal to the square root of 1/12. Now we'll do that on the calculator. So you go second, and that brings us to, you see that little blue square root right here? Then you can, after you hit second, you hit this, and it'll take you to the square root. Then you go 112 equals 10.58. Yeah, that looks right. 10.58. So B is equal to 10.58 what? Nautical miles. Love our units. So 10.58. B is equal to 10.58. And you could double check. Does that make sense? Yeah, it's a little bit shorter than 11. So this hypotenuse, this one across from the 90, will always be the longest. And so this one should be a little shorter, which it is. And now that we have that distance and we're given a speed, we can figure out how long it would take us to travel this distance. So distance, speed, and time. What's our distance? We just got it, 10.58. 10.58 nautical miles. What's our speed? 14. 14 nautical miles per hour, right? 14 knots. What's our time? If we use our little D Street helper, time is distance over speed. Distance over speed. So our distance is 10.58. 10.58 nautical miles over 14 nautical miles per hour. Nautical miles cancel out, you're left with hours. And what's that? 10.58 divided by 14. Let's check that out. Oh, look, it's already on our calculator. So we just go divided by, that ANS is our former answer. 1/4 equals 0.755. So we're going to say 0.76. 0.76 hours. Okay, good. Then that makes sense, right? Because if the distance is 10 and we're going 14, it doesn't quite go in one time. Good. So now this hours, we can't add 0.76 hours to 21. That won't look like any time we've ever seen. So we need to get it into minutes. So you times it by 60 minutes over 1 hour. These hours cancel off, and you get 0.76. And what's a 0.76? Just in your head, you're going to be like, almost 45 minutes, right? If it was 0.25, it'd be 15 minutes. If it's a 0.5, it'd be 30 minutes. 0.75 would be 45 minutes. So this is 0.76. It's going to be like 46 minutes. It's good to do that in your head so that we can get close. Oh, and look at that. It's already on our calculator. So just go times 60 equals 45.3. Yeah, 45 minutes. So it equals 45 minutes, right? And now if we add 45 minutes here, we say 21, 26 plus 45 minutes. 6 and 5 is 11. 1 here, 4, 5, 6, 7. 71, 21 plus 0 is 21. Okay, you see the 71? We need to take 60 out of here, which adds an hour over here. So this would be 11, right? 71 minus 60 is 11. We add one over here, 2211 would be our ETA. 2211 is when we should arrive here. Let's check. 3. Oh, I see it. C. We can double check our answers. 3. 3 is C. Excellent. So we'll just go on to practice problem 4. Be patient with yourself. Keep going. Give yourself time to just think about these. Don't try to rush through them. Just keep doing them, and you'll get this. Here we go.